All right, so I've had some questions about homework 16, which is 5.8b, and one question in particular, question 7. And let me go ahead and I'll pull up the picture of it. This is talking about hurricanes, and it gives us a bunch of data from every 20-year increment, starting from 1921 all the way through 2010. So here's your data. In order to make it quick and easy on yourself, using technology is probably the best way to go. I'm going to recommend that people do that. Here, let me go ahead and show you how to go about doing that. Turn it on, and then we're going to go to Stat, and under the Edit menu, you're going to take 1 or Edit. You can just hit Enter at that point. And I've already done the information about, the 20 years that was one, the next 20 years, the next 20 years. So I've already got this data already inputted. But you would put it into 2 lists. You would start with, you would probably be over here, and you would put, 1, 2, 3, 4, 5, all the way through, and then you would put your individual data, the values for your hurricanes, in the second list. And you will actually need to keep track of that, especially if you start doing anything strange. But generally speaking, list 1 and list 2. And then we can go ahead, and we're being asked to find the A times sign, and then you've got this, what is it? You've got a fee, and then I don't remember. This is a Greek letter. I don't remember what it is. But anyway, we've got this, and then the plus B. They want us to show how that information was, or what that information is, and I'm going to go through quick. Didn't mean to do that one. Whoops. So here I have the amplitude, which is the A. You take the largest minus the smallest divided by 2, and ultimately you have the 40 minus 23, 17 over 2. I put it into decimal. When you go ahead and put it into the calculator, you are going to need to check whether you're putting it in as decimals or fractions or integers, and if they want any rounding. You need to be super aware of that, because it will mark you wrong, and it becomes problematic if you have the right answer but you didn't round it correctly or whatever. So anyway, here's our amplitude, our vertical shift, which is the largest plus the smallest divided by 2, so that gives us a 31.5. Our T is measured, and I'm going to go ahead and pull this back up, and we'll plot, we'll go ahead and plot this information. We'll go ahead and turn this off. I want these two both off for the moment. So if my equals are not highlighted, then that means these are not going to show up on my graph. So I'm going to go ahead and draw my graph, right? And you can see that it's comes down, and it goes back up here, and then it comes back down, and then it comes back up. Okay, so I'm looking for my maximum to maximum. All right, the way I'm going to do that is I'm going to hit my trace, and if you take a look, it's giving me 0.1 in list 1, list 2. So they're plotting this, list 1, list 2, and so there's my first one. My x is 1, my x is 2, right, 3. All right, so here I have a 4. That's my maximum. And I go from 4, 1, 2, 3, 4, 5. So maximum to maximum is 5, 2 centuries, or 2 decades. All right. So in this case, we're able to figure it out. Our T is 5. All right, so I use from 440 and then 940, and then we set that equal to t, right? So 5 is our t. We want our, I'm going to call it w for lack of a better word, we want our little w symbol here. We want that to be equal to our calculation here. So we've got 2 pi over the w equals t. Well, that means 5 equals 2 pi over w. When you multiply by the w and then divide by the 5, this is what you get, 2/5 of pi. When you go ahead and plug it in, we don't know whether we need a horizontal shift yet or not. So we're going to go ahead and plug this in. Okay, so we've got our 8.5 sine 2/5 pi, and then since we don't know the horizontal shift, I'm going to put a placeholder in there. I put a -0, and then my plus 31.5. So let me go in. I'll show you that I did that. There's actually, we're going to use this. So here I've got my 8.5 sine 2 pi over 5 times the x. Oh, that's what I left off. Let me go ahead and add that on here. It's kind of a little awkward to put that in there, but that's what it is. We can do, because there's commutative, we can go ahead and do 2/5 x times pi. Anyway, so here we go. We've got that x, and then I go minus 0.0, and then I close the parentheses and plus 31.5. Okay, I go ahead and graph that, and you can see it's following the pattern, but it's not, they're not overlaying the data points, right? It's not showing the data points exactly. So if we take a look, we want to, there's a horizontal shift that we've got to deal with. All right. So in this case, we go about looking for our maximums on each of these. So here I have a maximum, and here I have a maximum. I listed these guys out. So the max of the function, right, is going to be 1.25. If you don't know how to find a maximum, there's actually a really slick way of being able to do that. You're going to go second and trace. That says calc right above it. And here you can scroll down to minimum or maximum. And I'm going to go, you want to go to the, you don't want to be right near the maximum. You want to be very clearly on one side or the other. So I'm going to go way back over here. There's my left side. That's where it's going to start looking. Now again, I want to be way past that maximum so that I'm sure that I've captured it. So I go ahead and hit enter there. It asks for a guess. I figure that I'm paying for the electricity. Go ahead and just give me an answer here. So you can see that that's a 1.25, and that, 0001. I'm going to just disregard that because it's 1.25. All right. And then I'm going to do the same thing for my maximum over here. Right. And here I wound up having, I've already found that, right. That's a 40. And that happens at 4 and 40. So now I'm going to take this and I'm going to subtract, right? I've got my 4 minus 1.25. That's going to give me 2.75, which when you convert it to a fraction is 11 over 4. Now taking that 11 over 4, I'm going to plug that in so that I've got this 2 pi over 5 multiplying x minus the 11 over 4. And be careful, this number here is not the end. This is not the end. You need to plug this in before you, and then go all the way through the process. Right? So you're going to have here you're going to have the minus 11 tenths pi rather than 11 fourths. Okay, so you actually have to do the math here. And when you do that, you're going to find here's your horizontal shift. Okay, and taking a quick look, we want to go ahead and where did I put it? Let's take a look here. There we go. So here's our original one, right? Here's our original function. I'm going to go back in. I actually entered it twice just so that we could see it. And here I put in my 11 pi over 10. All right. And so I'm going to turn this one on. And if you take a look over here, here's the regular line, right? If you go over here, you can see on the second one I have dash dots, okay? You can pick all kinds of things. There, we're back to the original. We can go really dark. We could shade above and below. We could do dots with lines connecting them, just the dots. And then here's a much finer dot, and I actually like this because you can kind of see where the points are and see that they really are overlaying on those points. So we're going to go ahead and graph that. And that's looking really good. All right, so this is the dashed line. This is the one where we have the horizontal shift in there. The horizontal shift looks wonderful. And we're going to go ahead and key that all in. All right, so there's our 17 over 2 sine 2/5 pi x minus the 11 pi over 10 plus 63 over 2. Now, I know that I put some of that stuff into decimals, but if you take a look, it says type an exact answer using pi as needed. Use integers or fractions for any numbers in the expression. So they're telling you do not use decimals. Okay, so that's why I have to do this 17 over 2 and the 63 over 2 and so on. All right, and let's see here. When we go ahead and put that in, went ahead and did it, and it tells me nice work. And then we go, let's take a look here at our all right, they wanted the graph as well. All right, they wanted us to check the graphs. So here, I want to point out that there are little magnifying glasses, and you're able to make this bigger. And I actually really like this being able to overlay, right? If it's a little too busy for you, it's certainly easy to go back in and turn off the one that is the solid, because that was the one without the horizontal shift. And go ahead and graph that again. And now you can take a look at where the dots fall, and as it stands right now, this was the one that was the closest of any of these. So I went ahead and selected that, and it says nice work. So it's on its way. Anyway, I figured I would let you guys know. You can go ahead and use, okay, in this case they want us to go ahead and use the calculator. And in this case, I can go show you how to do that as well. We're going to go second and trace. If you take a look, there's a calc up above. So we're going to calculate, well, actually, I want stat. Sorry about that. So stat, calc, right? So I'm going to go into that one and calculate. And if you go all the way down, so that we're going to have a sine regression. So we're taking our data points and plugging them in. And so if we do that, we need to tell, we're taking that sine regression, and then we have to tell it which lists to look at. And it kind of defaults to 1 and 2, but I want to be sure that